everybody, it's Dahl from Scorpion Power Systems. Today we have a really exciting video for you all. So manufacturers often have the same size of airplane but with different models. And I see people ask all the times, which one should I get? Also, I myself wonder, what's the differences between these models? Not just in the flying characteristics, but also the build features, the build quality, and everything like this. So in this video, we're going to be putting the Skywing 67-inch Edge and the Skywing 67-inch ARS head to head, and we're going to be doing a deep dive comparison of these two models. Both of these models have a 100% identical setup in them, so this is going to be a true apples to apples comparison. For the power system, they are both using the Scorpion A-4225 PNP Combo. If you don't know what that is our Scorpion Power Systems Power System Plug-and-Play Combo. So it comes with our new A series 4225-500 kV motor, and it pairs it with our Tribunus 2 06120 amp ESC, which is a super powerful ESC with a HV BEC. Also included is our Scorpion Backup Guard 2 power board, which plugs into a small 2S LiPo and provides backup redundant power system for your model. As well, there's some accessories included, such as our anti-slip lock strap, and as well there's some thrust washers included, so you can get fine-tuned spacing for your spinner to cowl placement. The best thing about this PNP combo is that it comes pre-soldered and pre-programmed. So the only thing you need to do is mount the battery connector and then do a stick throttle calibration with your radio. The entire power system is run in at the factory. The motor is checked for balance and function, and the ESCs go through a 5-time quality control inspection where they're also run in under high load for an extended period of time, guaranteeing that the motor and ESC that you get is going to work great on your model and you're not going to have any issues. For servos, they both have the Xpert RC MM3301-HV servo, which is a high voltage metal case metal gear servo. Super fast, super strong. I love it for this size of the airplane. For the propeller, they're going to be using the same one, like literally the same one. I found out that I only have one propeller and 2 planes, so they're going to be sharing. This is the Falcon 18x10 C2E, which is a monster prop for this motor. Alright, so let's jump right into it. I'm going to be dividing this video up into 3 sections. So there's going to be build features comparison, then we're going to go into aerodynamic design differences that I can measure and observe here on the bench. For the 3rd section, we're actually going to head out to the flying field and we're going to fly these planes back to back. We'll observe how they fly, what characteristics they have, what things they do better. Not so much to find out which plane is better, but just to note the characteristics so that you can find a plane that best suits your style. To start off, I'll just talk about the overall build quality of both of these planes. So both of these planes had absolutely fantastic build quality. The covering work on each plane was super good, hardly any wrinkles, and all of the lines were really crisp and really straight. No real issues here. Same goes for the paint work. The quality on the paint is all really good. No issues with any runs or fuzzy lines. Everything is crisp and straight, and all of the lines match up. So I'm really pleased with both planes on the covering quality and the paint quality. Both kits come with pre-hinged and gap-sealed ailerons and elevators, and then all you have to do is mount both of the rudders, which is pretty typical for any airplane nowadays. Both planes come with quick-release canopies, however the mechanism is a little bit different. The ARS has a top pin here, which you pull back and allows you to take the canopy off. And then the Edge has just a magnetic dowel pin that you pull out, which allows the canopy to then come off. Both planes have quick release wing mechanisms. It's 100% the same mechanism, just the handle is a little bit different. The ARS has kind of a metal handle, which allows the wing to come off, whereas the Edge has a carbon handle, allowing the wing to pop off. But both are equally convenient and equally strong. Both planes come with carbon fiber landing gear and these wheel fairings, which are really nice. The ARS has a painted landing gear, whereas the Edge shows you the carbon fiber, but that's just the aesthetic of the plane. But as far as function of the landing gear, fairings, and wheel pants, it's all 100% the same. Lastly, all planes come with the same hardware. So they all include the ball links, the linkages, some servo extensions, Velcro straps, bolts, everything like this. Now let's go ahead and we'll move on to some of the differences of these planes. The biggest design difference on these planes has to do with how the elevators mount to the fuselage. On the ARS, it has a two-piece elevator which glues together with epoxy and some carbon tubes. So the two sides come together around the fuse, and then also the two halves of the elevator are joined by a single carbon rod. Compared to the Edge, which has a single piece elevator which just slides in from the back and glues into place. Functionally speaking, both of them are fine. Both mechanisms auto-align the stab levelly and rotationally, so there's no real need to do alignment or trammeling, which is nice. But I will say that mounting the Edge elevator was a little bit easier. I just slid it in and glued it into place, no issues. The ARS took a little bit more gluing and a little bit more wiggling, but both work, but my preference again is with the Edge. Another difference is that the ARS is designed to actually accept two elevator servos should you choose to. So each half of the elevator could get its own servo even though they're connected by a carbon rod. The ARS is an older of a plane. It was the first 67-inch that Skywing made. So I think they were worried that the mini servos wouldn't be strong enough for such an elevator. So they put two in so that you could have double the strength. But nowadays with the new high torque servos that we have, just one is fine. In my opinion, I only put one and I think it'll be just fine. Both planes are just wanting one Xpert MM3301 servo. Also, there's a difference in the rudder control method. The Edge is designed to have a direct rudder control, so the tail servo is in the back and is connected with a linkage directly, whereas the ARS has the rudder servo mounted in the front and is connected with pole cables. I think they did this because this plane originally was going to have two servos in the tail, so they didn't want the weight or they didn't have space to put a third servo in the tail. But yeah, this one has pole. You know, pole is a little bit harder to set up. You gotta string the wires and crimp it and everything, which is a little bit more of a pain. So again, my preference goes to the Edge, but of course both are gonna work just fine. Another visible difference is that the ARS comes pre-mounted with a pilot inside, whereas the Edge does not have a pilot inside. So that might be a selling point for some of you. Personally, I don't care, but some of you might find that interesting to note. Both kits come with side force generators. The ARS has a design where you have to take the little thumb screw out all of the way before you can get the side force generator off, whereas the Edge does have a quick release system, which is much more simpler and easier to do. So that's a really nice feature about the Edge. The fuselage construction on both planes is almost identical. They're both with that fiber plated plywood. So I think the fuses are both equally as strong. About the wings, I do note that the D-box on the ARS has some cutouts in it, whereas the Edge wing has a completely solid D-box. And if I twist the wing, I can note that the ARS is a little bit more flexy in the wingtip than the Edge. I'm not sure how that would affect flight, but it's something to note. Both kits come with a spinner, however, the material is different. The ARS comes with a fiber spinner, which mounts with 6 bolts around the ring, as the Edge has a plastic spinner, which mounts with 2 bolts from the front, and it has some cooling slots cut into it. The next difference has to do with the motor box, so I'm going to take the cowl off both planes, and then we'll get back to the video. Under the cowl, we can note that the ARS motor box comes all the way up, and the motor mounts more or less directly to it, whereas on the Edge, it has the motor box comes here, then it has this motor box extension, and then the motor mounts to that. The reason for this is because the Edge actually allows to mount a gas 20cc engine to it if you want. So the gas engine is a little bit bigger and requires some more space. So if you were using this plane on gas, you would have this motor box off and the gas engine would mount to here. But with electric, they make this extension and the motor mounts to here. So that's the main difference and the main reason for this. The Edge can accept a gas engine if you want, whereas the ARS is electric only. That's everything I can note about the build and the design features of the planes. Now let's go in and we'll look at some of the aerodynamic differences of the planes that I can note here on the bench. So first up is airframe weight. I was a little shocked about this. On the website it shows that the Edge is actually lighter than the ARS. But as I said, both planes have an equal setup in them. So my setup with the 6S 5500 milliamp 45C battery, which is about the heaviest battery you would use, but my setup on the ARS is 8.4 pounds, which is about 3.8 kilograms. Whereas on the Edge, it's actually 8.6 pounds with the same battery, so 3.9 kilograms. If I take the battery out and measure the airframe only weight with servos and with power system, the weight on the ARS is 6.6 versus 6.8. It's only about a 2% weight difference, so they're almost equal, but it just did shock me because I thought that the Edge would actually be a little bit lighter, but it turned out it was the opposite. The wing design, according to the website, the ARS has 849.8 square inches of wing area, compared to the Edge, which is 891.25 square inches of wing area. So the ARS has about 5% less wing area. Of course, obviously with the Edge wing, it has more of a straight leading edge, whereas the ARS is a bit swept back. So that might make up for the additional wing area on the Edge. For the chord length, the chord at the root on the ARS is 410 about, and on the Edge it is 430. So the Edge is about 20 millimeters of a wider wing at the chord, and at the tip, the ARS is 205 millimeters, where the Edge is 220 millimeters. The combination of the wider chord and the non-swept wing gives a little bit more wing area for the Edge. The wing thickness, we'll go ahead and measure that as well. The widest point of the chord on the ARS is 45 millimeters. Widest point on the wing of the Edge is 43.5 millimeters. At the tip of the ARS, at its widest point, it is around 26.5 millimeters, and the Edge is also about 26.5 millimeters. In summary, the ARS wing has a little bit less wing area, so the overall plane will be a little bit higher wing loaded. The chord width at the root and the tip is a little bit smaller. At the base, the airfoil is a little bit thicker, but at the tip, it's about the same thickness as the Edge. And of course, the ARS wing sweeps back a little bit. As compared to the Edge, which has more wing area, so a lighter wing loading, has a wider chord and a wider tip, although the airfoil is a little bit thinner at the root, but about the same at the tip on the thickness as the ARS. Now let's compare tail feathers, so I'm going to flip the planes around. The wingspan of the elevator on the ARS is 750 millimeters compared to the Edge, which is 732 millimeters, so a little bit less on the Edge. As far as the width, the ARS at its widest point is around 240 millimeters, whereas the Edge is 230 millimeters. For the proportion between the horizontal stabilizer and the elevator, let's go ahead and measure and do some quick math. So measuring in the center of the surface, this is the horizontal stabilizer is 85 millimeters, and the elevator is about 135 millimeters. 135 divided by 85 is about 1.6, so the elevator is 1.6 times the size of the horizontal stabilizer. Comparing that to the Edge, measuring in the middle, the horizontal stabilizer is about 90, and the width of the elevator is 135 again. So 135 divided by 90 is about 1.5. So the Edge actually has a little bit smaller of an elevator, and the proportions between the horizontal stabilizer and the elevator is actually in the favor of the ARS. So it seems that the ARS might actually have a little bit more elevator authority, but we'll see in flight. I'm going to try to measure the thickness of the surface, but it might be a little bit difficult since it's mounted. On the ARS, I've got about 23 millimeters, where on the edge, maybe a little bit thicker, 25 millimeters or so. And then measuring at the tip, the ARS has a maximum width of 19 millimeters compared to the edge, which is about 23 millimeters. To summarize, the wingspan on the ARS elevator is a little bit bigger. The elevator itself has a little bit more chord width, and the proportion between the elevator and the horizontal stabilizer is a little bit more aggressive, but this surface is thinner overall than that compared to the edge. Whereas the edge has a little bit shorter of a wingspan, has a little bit smaller of an elevator chord width, and the proportions between the elevator and the horizontal stabilizer is a little less aggressive than the ARS. One last thing to note is the sweep angle. On the edge, it's not completely straight, it angles back a little bit, but on the ARS it does angle back a little bit more. Last surface to inspect is the rudder. So let's measure. On the ARS, the height of the rudder, maximum height of the rudder is around 340 millimeters compared to the edge, which is 360 millimeters. As far as length, I'm going to measure from this point to back to the surface. It's the easiest measurement I can make. On the ARS, that's 260, where on the edge, let's call it 300. For the proportion between the vertical stabilizer and the rudder, again, I'm going to measure at this point. Here is around 120 millimeters of the horizontal stabilizer compared to 140. So that's a little bit above maybe 1.1 or so. I'm not even going to do the math. And as compared to on the edge, this is 135 compared to 160, which is maybe 1.2 or so. Again, I'm not going to do the math. To summarize, the rudder on the edge is much bigger, it's much taller overall, and it has a greater chord. And even though the vertical stabilizer itself is also wider, the proportion between the vertical stabilizer and the rudder is also more aggressive than on the ARS. So the ARS has a little bit smaller of a rudder and a less aggressive proportion between the vertical stabilizer and the rudder. As far as the width, again, it's almost impossible to measure with the tools that I have, but I can guess maybe 20 millimeters, where on the edge it is definitely a bit wider, maybe 26 or so. So the edge as well has a wider rudder. That's all of the surfaces. Now I want to move on to the fuselage and look at the side area and the tail moment. To measure the tail moment, I'm not actually sure the proper method, but I'm just going to measure from the wing tube back to the front of the elevator, the horizontal stabilizer. To measure the moment, I'm not actually sure the proper technique, but I'm just going to measure from the wing tube back to the front of the horizontal stabilizer. So here we have around 760 millimeters as compared to the edge, which is around 780 millimeters. So I'm not sure that's the proper technique, but it does seem that the edge tail moment is a little bit longer. For the side area of the fuselage, again, it's going to be hard for me to measure this accurately, but I will just approximately say that at the widest point, the ARS is around maybe 235 millimeters compared to the edge, which is around 260 millimeters. In summary, the fuselage on the edge has a little bit more side area and it has a little bit longer of a moment compared to the ARS. For the proportion between the aileron and the fixed section of the wing, I'm going to take some measurements now and then we'll go ahead and put the ratios up on the screen because I'll do the math later on. So measuring at the root, the aileron is around 135 millimeters and then the wing is around 260. So it seems around 2 to 1. On the tip, the aileron is 65 millimeters and the wing root is 138 millimeters. Comparing to the edge, at the root, the aileron is around 128 millimeters, and the wing is 275 millimeters. At the tip, the aileron is around 78 millimeters, and the wing is 142 millimeters. That's about everything that I think I can measure on these planes. All of the surfaces, the proportions, the ratios, everything like this. To summarize again, these are both 67-inch airframes. They have the exact same Scorpion A-4225 PNP Combo, as well as the same Xpert MM3301-HV servos. They're using the same 1.25-inch metal servo horns on the ailerons, 1.5-inch on the elevator servo horns. On the edge, the rudder is also a 1.5-inch horn, but of course on the ARS it's pole-pole, so I'm actually using a 2.5-inch dual-sided metal arm for the rudder pole-pole. Both planes will be running on a 6S 5500 mAh 45C battery with the Falcon 18x10 C2E prop. Now let's head to the flying field and we're going to compare these planes in the air. The Edge I've flown a lot. I have hundreds of flights on this plane and I absolutely love it. The ARS I've actually never flown before. I just finished building it. So this is going to be a great experience for me as well. At the flying field, we had a very successful day of flying. We got there and I put the Maiden on my ARS. I got it all set up and tuned to my liking. And then we began the comparison between these two models, the Skywing 67-inch Edge and the Skywing 67-inch ARS. I flew each plane back to back and I think I found some maneuvers and flying sequences which really show and highlight the key differences between these planes. Again, I'm not trying to find which plane is better or worse. Each plane flies amazing and truly great in their own respective styles, but they are a little bit different. So let's go through and find some differences, and then you can make an informed decision about which plane you think would suit your style more. First up, we'll compare how the planes take off. The Edge takes off very beautifully, no real comments there. The ARS does sit a little bit more tail down, so it might transition off the ground a little bit easier, I will say, than the Edge, but very minor point. First thing to compare is how the planes snap roll. So you can see here the Edge, it does snap rolls really fast and not with a lot of deflection. So it's kind of what I would call more a 3D snap, or like IMAC guys would call it a fake snap, where the plane just kind of does a little corkscrew, but doesn't show a lot of departure or anything like this. It's more of a 3D snap. Compared to the ARS, it has a much more IMAC style snap. So a little bit slower, has a little bit more deflection while doing the snap rolls. It doesn't snap slower, I would say, but you just need to be going a little bit faster to make it snap quicker. So if you like more of an IMAC style snap, the ARS would be a little bit better, whereas the Edge is more of a 3D kind of really fast snap roll. Next, let's compare how the planes break loose in the air. So some maneuvers like a pop top, for example, is really apparent. You can see the Edge, it comes in and it has a wickedly fast pop top maneuver. So it really just spins around like crazy. And then you can see there at the bottom, it just flips and goes the other way. It's really 3D. Compared to the ARS, it does the same maneuver, but just with a little bit less aggression. A bit more predictable, a bit more slower. It's just not quite as easy to break loose as the Edge. With the ARS, if you come in fast and you hit it really hard, you can get it to break loose, even faster than what was shown in the video, but just the Edge breaks loose a little bit easier. Another factor I paid attention to was how the planes do point rolls. So first up is the Edge. Now you see on this point roll, I actually climbed up on the first point. That's because the Edge has so much side area that I just instinctively give a little bit too much rudder. And I often find that on my point rolls I climb up because it just has so much rudder authority. But of course, if I hit the rudder right, the plane does point rolls beautifully without a complaint. Comparing to the ARS, it has a little bit more, I would say, standard rudder authority. Even you can see there, I was a little bit late on the rudder and had to jam it, and the plane didn't climb up, it just kind of mushed. So that's more what a standard plane would do, I would say. But of course, if you hit the rudder right, both planes do point rolls absolutely beautifully. Just the edge has so much side area that you need to note that, whereas the ARS feels a little bit more traditional. Next has to do with how flippy the planes are. So the maneuver like a Lamschwach. The edge here is wickedly aggressive. You can see it just tumbles over and just keeps tumbling. However, the ARS also tumbles just great. A little bit less aggressive than the edge. You can see the edge is just a little bit more aggressive and a little bit faster, whereas the ARS is a little bit more controllable, but still equally as capable, I would say. So not much difference here, actually. Comparing how the planes do slow speed flying and kind of hanging on the prop, you can see the edge is super floaty. It flips over on a dime. It transitions between slow speed and high speed really well. At slow speed, the edge really is just like on rails. Like you have so much control authority even at slow speed. It never does anything strange. It never does anything weird. Just wherever you put the sticks, it goes. So that's one thing about the edge. It's just super responsive for slow speed flying. Comparing to the ARS, it also has great tail authority and roll authority in slow speed, but it does struggle a little bit more. You can see here on the screen, I had a little bit more trouble keeping the plane going where I wanted it to. Sometimes it fell out. Here you can see the nose dip down a little bit while I'm trying to harrier, compared to the edge, which just always stays exactly where you want to put it. So the ARS, while it can do all of the slow speed stuff, it has great tail authority. It's just a little bit more, it's just not quite as much of a 3D plane as the edge is. But it does do very precise slow speed. Maybe you just have to fly it a little bit faster, but it's still capable of doing all the maneuvers. Next up, we'll compare how the planes do kind of high G pushes, what I call. So I'm doing a figure 8 maneuver with snaps in the middle. The edge at high speed and these pushes, it's a little bit unpredictable. So you can see I have trouble here. Sometimes there it stalled out a little bit. You can see on repeat, I did a really hard push and the plane kind of stalled out. Also, it was pretty windy today, so in those maneuvers there was wind rocking the plane around. The edge was a little bit more affected by the wind as compared to the ARS, which was just on rails. So no matter what I'm doing, how much wind there was, the ARS just really was very locked in, very true and very precise. For high speed flying and high G maneuvers, the ARS really shined. On the opposite end of the spectrum, we'll compare how the planes do slow speed Harrier rolls. So you can see here the edge does them really beautifully. It has a pretty consistent roll rate. The nose quite easily stays up high. You can do these Harrier rolls really slowly and really precisely. You can see in a couple places where the nose gets a little bit too high and the plane kind of loses its forward speed, causing the roll rate to sometimes be a little bit inconsistent because the nose gets too high and the plane slows down too much. But it does do rolling Harriers really well. The ARS, on the other hand, also equally is capable of this maneuver, but you can see that it's a little bit more nose down. So the nose doesn't just stay up as easily as it does with the edge. You have to keep a little bit more forward speed, but the plane is still does them beautifully, just not quite as 3D and floaty as the edge is. And I'll stop right here. Maybe some of you are going to say, oh, well, the edge might have just been more tail heavy. I, of course, did take this into account, and I tried to set both planes up to have an equal CG. I did the standard CG test, like trim it for level flight, roll it inverted, and see what happens. So both planes were set up to where I trim it for level flight, I roll inverted, and they just fall ever so slightly. They don't push, they don't drop completely, but just fall ever so slightly. So I would say that, comparing plane to plane, the CG was set almost identically. Next test has to do with just elevator authority in these kind of slow speed flips. So up first is the edge. You can see it just whips itself around with absolute ease on these kind of slow speed flips. It does have tons of elevator authority. But the ARS as well does have really good elevator authority. On this first flip, you see I struggle a little bit, but I found I just need to give a little bit more throttle, and then the plane does the flips just as good as the edge, I would say. But it takes a little bit more throttle to get the plane to flip, but it is equally as capable. Next test has to do with just elevator authority in these kind of slow speed flips. So up first is the edge. You can see it just whips itself around with absolute ease on these kind of slow speed flips. It does have tons of elevator authority. But the ARS as well does have really good elevator authority. On this first flip, you see I struggle a little bit, but I found I just need to give a little bit more throttle, and then the plane does the flips just as good as the edge, I would say. But it takes a little bit more throttle to get the plane to flip, but it is equally as capable. Till now, both planes, while they're different, they're both capable more or less of doing the same maneuver. But the next category is one where I did note a pretty stark difference in the planes, and that has to do with high-speed rifle rolls. So up first, actually, we have the ARS. Now, I'm not the world's best airplane pilot, but I can do rifle rolls with the plane, and generally speaking, I can get it going where I want it to go in high-speed rolling loops and maneuvers like this. So you can see here on the ARS, I can more or less consistently keep the plane rolling on a straight line and make it go up and do the kind of maneuvers that I want it to do. However, with the edge, I have tried several different differential settings and everything, but I really struggle to make the edge do high-speed rifle rolls and rolling looping maneuvers. You can see here, I was trying to make it do a loop and it just kind of went off to the side, goes up. So that's one thing with the edge I never really got around or figured out how to make it do. I have several other planes, a Skywing Edge in G, laser, I have the ARS, the edge, and on all the planes I can make it roll and do the maneuvers like I want, but with the edge in high-speed rolls, I just never can make it do quite what I want it to do. Maybe it's me and my pilot skills, but that's just what I know. I would say, all I can say is that the ARS rolls more similarly to other planes that I have than the edge does. Lastly, we've got the landing speed. Both planes land beautifully, no comment here. They're both very lightweight and very predictable. It was quite windy today, so there was a lot of turbulence over the runway, but both planes landed beautifully and no comment here. Those are my main points and the key differences and similarities that I noticed between the planes. As a general overview, once again, I'm not going to tell you which plane is better or worse because that is 100% user preference, but I will just give a summary of my feeling of the planes, and then you can make the decision from there. With the ARS, it is a super true and clean flying plane. It does point rolls very predictably. It's very straight on up lines and level lines. The snap rolls are a bit more of an IMAX style, so they show very clean departure and are quite predictable in their speed and their stopping ability. For high-speed flying, the ARS really excels. So in high G and high-speed maneuvers, it really tracks straight and clean and true. Even in really gusty and bouncy wind, the ARS really just keeps on a straight line. Also as well, the ARS rolls really axially, one of the best rolling planes that I had. So I really like that for more high-speed flying, point rolls, precise pushes, stuff like this. However, the ARS still can get down and do some 3D. It's a very capable 3D plane. It can do all maneuvers that I wanted it to do. It has tons of elevator authority. It hangs on the prop well. It does all of the low speed and floating maneuvers that I wanted. Albeit, it does do this kind of slow speed 3D a little bit faster, so you got to keep a little bit more speed, use a little bit more throttle to make the plane do what you want it to do, but it is capable of doing it all. And so it is actually a nice blend of a plane between high-speed precision and slow-speed flying, but a little bit more catered to the high-speed and precise flying than the slow-speed flying. Once again, here you can see in these high-speed and high-G pushes, the plane is just on rails. It has tons of rudder authority still, as you can see in these knife-edge maneuvers. So overall, it is a really nice plane still to fly, and I do enjoy it immensely. Once again, for rolling capabilities, it rolls very true and very axially. I was able to do all rifle roll maneuvers, all rolling loop maneuvers, and everything like this. Overall, it's a great blend of an airplane, and I do enjoy to fly it. I just find myself, when I fly the ARS, I do a little bit more high speed, more point rolls, snap rolls, and high speed maneuvers and stuff like this, because I feel that the plane, that's just naturally how it likes to fly, and that's what it really excels at. Comparing this to the Edge, there is some similarities in the planes on how they fly. The Edge is also able to do some precise flying, but it is just a more crazy 3D monster. So when I fly the Edge, I find myself just doing more crazy extreme air acrobatics. I have the sticks in the corners more often, doing a lot of low speed maneuvers, Harrier rolls, flips like this, because that's where the plane just really excels. So you can see here in these rolling Harriers, it really stays nose up high, very predictable in the movements with tons of elevator authority. You can see that double flip right there. In high speed, you know, it does track well and it does all right, but it's just not as graceful and not as precise as the ARS is. In these high speed, high G maneuvers, you can see here, like, I kept the speed a little bit slower. So with the Edge, I had to maybe fly this at about half throttle to keep the speed down, to keep it a little bit controllable. With the ARS, I could go as fast as I want, and it just stayed true, where the Edge needed to fly a little bit slower in order to maintain really precise control. The Edge has absolutely crazy elevator authority for flipping and breaking loose maneuvers like the Lamschevak and pop tops. It does those with ease. And of course, once again, in slow speed flying, it really excels. You can see here it just hangs on the prop. When it's coming in and it stalls, it kind of stalls tail down, I would say. Like when it stalls, the tail drops, not the nose drops, if that makes sense. So it's really great for this kind of slow speed hanging on the prop line with a lot of slow speed maneuvers. It has excellent tail authority for flips and yaw maneuvers. So very predictable in the slow speed sector. Crazy power you can see there on that upline, and then coming down with again a crazy flip and spin right into some low speed flying again. That's where we ran out of memory on the SD card, but I think you guys get the point. The Edge is a really great plane to fly. I immensely enjoy flying it. I remember the first times flying it, I was so shocked at how capable it was. It's so light feeling and so crisp. It does really good flips, and it's allowed me to do maneuvers that I didn't even think were possible. It completely excels at the slow speed and kind of flippy flying. Of course, it's not as good in the high speed sector, not quite as precise. The snap rolls are a little bit more crazy and wild, like a 3D style plane. So if you get the Edge, you can expect a crazy 3D monster. So there we have it. That is my in-depth review of the 67-inch Edge and the 67-inch ARS from Skywing models. Both planes were equipped identically with the Scorpion A-4225 PNP Combo and Xpert MM3301-HV servos. Both planes fly absolutely great in their own regard. I can't say one is better than the other. All I can do is show you some of the differences that I noted, and then you can make your own decision. Thank you for watching this video, and I hope you enjoyed it. If you like this kind of comparison sort of style of video, then let me know. Skywing does make one more 67-inch, 67-inch extra in G, so it might be nice to have all three planes in here on the comparison. And I know the 67-inch is becoming a very popular size. Pilot RC has got some 67-inch airframes. Extreme Flight just came out with the 67-inch Edge 260, all of which would be great candidates for the Scorpion A-4225 PNP Combo. So who knows, maybe there'll be more comparisons like this. Let me know what you want to see. And thank you for watching. Bye-bye.